Hi class, so today we're going to be talking about how to solve a system of three equations from three unknowns algebraically. So let's see, here I have the system of equations, and there's three of them, and there's three unknowns, x, y, and z, three variables. And so we want to figure out and solve for x, y, and z. Now for a regular system of equations of two equations and two unknowns, you'd normally do substitution or elimination, getting rid of one of the variables that you could solve for the other. But since we have three variables here, you're going to actually have to need to eliminate two of them so that you can solve for that third one by itself. And so that means this solving is going to come in two waves. So the first wave, we're going to get rid of one of the variables, and then the second wave, get rid of the second one so we can solve for the third, and then work backwards. All right, so let's take a look at this. When we want to eliminate a variable or substitute, if we were to substitute, we would have to isolate for x or y or z in one of these equations. And oftentimes, because of the coefficients, you're going to end up with fractions. Now, fractions just make it harder to work with, especially by hand. So I generally don't use substitution when solving a system of three equations. I'll generally use elimination because it avoids those fractions. All right, so because this is a little bit tedious, you generally want to be strategic about which variables you eliminate, x or y or z. If you choose one, it'll work, but if you choose one a little more strategically, you'll just have to do less work. It'll be easier. So right now, I'm just going to default, I'm going to choose to eliminate x. And I'll show you later on that by actually eliminating y, that might have saved us a little bit of work. But for now, let's just go through the basic steps. So instead of taking all three of the equations together, we actually just want to take two of them together. Because if we were to eliminate the x's in all of them, you would still have two variables and a y and a z, and not be able to do anything with it. So we actually need two separate equations, and so we're going to pair these up. So let's pair up the first two equations first. And if we look at that, and if we want to eliminate the x's, it looks like if we multiply the top by a -2, then the x's will eliminate when we combine like terms. So it might look like this after we multiply the top equation by 2. And now we can go ahead and combine like terms, and you'll see that all the x's are gone, and we're left with 5y minus 5z equals -10. Cool. All right, next step. We looked at the first two equations. Now you can pick any other two equations. You could pick the first one and the third one, or the second one and the third one. Again, thinking strategically, 2x and 3x is going to be a little bit harder to eliminate than if we just took 1x and -3x. So I'm going to choose the first and the third equation. I'll rewrite them over here. And in order for the x's to eliminate, it looks like if I multiply the top equation by a 3, those x's will end up eliminating. So I'm going to do that and arrive at this new equation. And now these x's eliminate nicely, and we're left with -4y plus 7z equals 11. As you notice, we have y's and z's. We still can't figure out what y or z is. We want to combine this with the previous result and solve that system of equations. And that was 5y minus 5z equals -10. So basically this is now, we're going to do the second wave of solving now that we've eliminated the x's. So from here, I'm going to rewrite this for first equation. I'm going to divide by 5 to everything, multiply by 4 to everything. So now I can eliminate these y's. And so now I can take the red equation, the blue equation, combine like terms, and get z. Z is now equal to 1. Once you've figured out one of the variables, you then have to go in and plug in to get the other variables, x and y. So we figured out z is 1. You can pick either of these equations to plug it into. You don't want to plug it into one of these original ones because that still leaves you with two variables. If we plug it into one of these newer equations, we will be able to solve for y. So I'll just decide to plug it into this first one, plug 1 in for z, and I get y equals -1. Now, as you guessed, we know z is 1, we know y is -1. How do we find x? You can plug it into plug both of those into one of these original equations. So again, I'm just going to pick the first one and plug in z equals 1, plug in y equals -1, and where we can solve that x equals 2. So x equals 2, y equals -1, z equals 1. That is the solution to the system of equations. That is the point that all three planes would intersect on the graph. And it is they're the only three values for x, y, and z that make all three equations true, okay? All right, so we did it this way. That may have been a little bit quick, a little bit confusing, so feel free to pause and go through step by step. But I'm just gonna do it another way, where instead of eliminating the x's, we eliminate the y's first and see if that saves us some work. So if we wanna eliminate the y's, it looks like a -2y and a +2y would eliminate quite easily. So actually, if I would turn this middle y into a +2y, that could also eliminate with the first equation. So strategically, I'm just gonna multiply that second equation by 2 to get 4x plus 2y plus 2z equals 8. And now you can see these middle y terms, when we pair them up, we'll be able to eliminate pretty easily. So I'm gonna take a look at the first two. We combine those, the y's cancel out, and we're left with 5x plus 5z equals 15. And I'm going to look at the bottom two. Oh, sorry, the top one and the bottom one again, because the -2y and the 2y looks like they'll eliminate pretty nicely. And then once we do that, we are left with -2x plus z equals -3. Now, as you're working through this algebra, there's a lot of easy mistakes you can make with negative signs or forgetting to multiply all the way through. So you just have to be very careful and check your work often, because one little negative sign or positive sign, or forgetting to multiply by a number once, doing a subtraction or addition wrong once, is going to make the whole thing wrong. So you just have to be very diligent in making sure that your arithmetic multiplication and all that is correct. All right, so now we've got two equations with two variables, x and z. So we're going to have to combine these to solve for x and z. You can do it a number of ways. You could divide all these by 5 and multiply. I'm just going to multiply -5 to this one on the right so that the z's will cancel. Once I multiply -5 to the blue equation, I will get 10x minus 5z equals 15. And you'll notice those z's eliminate nicely. And we are left with 15x equals 30, so x equals 2. That's the same answer that we got last time around. And that's what we should expect. Just like before, you can plug the x equals 2 into either of these to solve for z, and plug x and z back into one of these original ones to solve for y. If you have any questions, come to office hours, and that's about it.